Okay, so let's start with the questions. So this is question 1. All right, so in this question, okay, is fairly straightforward. We are asked to just find the load current, okay, and the corresponding power efficiency for the load. So in terms of current, basically you know the formula, correct? V by R. So 12. Also the internal resistance here is 0.15. So this is 0.15. Okay, and now the load is 10 ohm. So plus 10. So in this case, I will get 1.18 ampere. Okay. In terms of efficiency, you know, it's basically power to the load over the input power. So the power to the load, okay, you can calculate as I square R. So it's 1.18 square multiplied by the RL, which is 10 ohm, divided by the input power, which is the voltage and the current, which is 12 multiplied by 1.18. So you'll get an answer of 98.5%. Okay, so that is the current and the power efficiency for the load. Okay, if my load is 10 ohm. Okay, now what if my load is 1 ohm? Okay, if my load is 1 ohm, what happens? So it's the same thing. I got 12 volts here, I got 0.15 here, and now my load is 1 ohm. Okay, so the current would have been 12 over 1 plus 0.15. So you can see that the current would shoot up tremendously. Okay, 10.4 ampere, okay, compared to here, which is 1.18. So the current has shot up tremendously. And if you look at the efficiency again, it will be 10.4 square multiplied by 1 divided by 12 and 10.4 VI. So that will give me, 84%, so 87%. Okay, so you can see that when the load resistance in this case has dropped, okay, your current has shot up. Okay, but most importantly, the efficiency has dropped. So why has the efficiency dropped? Because when your current starts to go up, the power loss at the internal resistance is higher. Okay, so the internal resistance power loss is higher compared to here. Okay, when your current is small, okay, the power loss experienced by the internal resistor is smaller. So there is more power delivered to the load. Whereas over here, since you lose a lot of power internally, the efficiency has dropped. Okay, so this is basically sort of trying to reinforce the concept of why the internal resistance of a power source or a battery is critical, correct? Because you want to deliver as much power as possible to the load. Okay, so this is resistance or voltage drop across some resistive components before you reach the load can be quite significant. Okay, even your USB cable, okay, that you use to charge your phone. Okay, different cables have very different efficiencies. Okay, we have seen that a lot, where when we measure some cables from 5 volt, you get close to 5 volt. In some cases, the voltage can drop significantly to 4.5, 4.4, or so on. That means the voltage drop through the resistance of the cable itself is so much. Okay, so these are things that we generally overlook, okay, but actually they can play a part.